Hey guys, so welcome back. Today we'll be talking about rational numbers versus irrational numbers. Okay, so remember when you are dealing with a rational number and you have a number, you're trying to see if that number is rational or irrational. You need to remember the definition of rational. Rational, think of ratio, a number that you can write as a fraction or ratio. So we're just going to add a note. We're going to say fraction or ratio. And then when you have decimals, is it a terminating decimal or a repeating decimal? If yes, then that decimal number will also be a rational number. Now, when it comes to irrational, so irrational numbers are the total opposite of rational number. So irrational numbers are numbers that you cannot write as a fraction or a ratio. Okay. And when it comes down to decimals for irrational numbers, if that decimal number is not terminating or not repeating, then that decimal number is irrational. So for an example, let's say we have the number 0.532. 0.532 is rational because 0.532 is a terminating decimal. It ends. If I have 0.5321987, on and on and on, then 0.5321987 without stopping or repeating is irrational. What about 0.25? 0.25 is also rational because 0.25 can be written as a fraction or a ratio, which equals 1 over 4. And 0.25 is a terminating decimal. It ends. 0.25988710, on and on and on. This number here would make it irrational. So it's not terminating, not repeating. So therefore, 0.2598710 is irrational. What about 7 over 5? 7 over 5 is rational because 7 over 5 is expressed as a fraction or a ratio. But if I had the square root of 7 over 5, that would make it irrational because the square root of 7 is already irrational, which makes the square root of 7 over 5 irrational. Also for this example here, since the numbers 7 and 5 are integers, this makes 7 over 5 rational. 7 over 5 is also written as a simple fraction. And for this example here, since the square root of 7 is not an integer, the square root of 7 over 5 cannot be written as a simple fraction. Therefore, the square root of 7 over 5 is irrational. Okay, what if you had the square root of 25? The square root of 25 is rational because the square root of 25 is a perfect square, which equals 5. The square root of 2 is irrational because the square root of 2 cannot be written as a fraction or a ratio. What about the square root of 9? The square root of 9 is rational because the square root of 9 is equal to 3. And the square root of 9 is a perfect square. If you had the square root of 8, the square root of 8 is irrational because the square root of 8 cannot be expressed in a fraction or a ratio. So let's say you had the number 9. Is the number 9 a rational number or an irrational number? The number 9 is irrational because the number 9 can be expressed in a fraction or a ratio. 9, if I turn it into a fraction, is going to look like 9/1, an imaginary 1. Okay, so therefore, 9 is rational. What about pi? Is pi rational or irrational? Pi is irrational because the decimal number for pi is going to be 3.14159, and it goes on and on and on without repeating or terminating. So pi is irrational. What about -4/5? Is -4/5 rational or irrational? -4/5 is rational because -4/5 is expressed as a fraction and or a ratio. What about the square root of 36? Is the square root of 36 rational or irrational? The square root of 36 is rational because the square root of 36 is going to give you 6. The square root of 36 is a perfect square, just like the square root of 25 and the square root of 9. What if I give you -12/4? Is -12/4 rational or irrational? 12/4 is equal to -3. Okay, so -3 is a rational number. What about the cubed root of 40? Is the cubed root of 40 rational or irrational? The cubed root of 40 cannot be expressed in a fraction or a ratio, so the cubed root of 40 is irrational. Okay, now what about 10 pi? 10 pi is irrational because 10 pi cannot be expressed as a fraction or a ratio. All right, and then what about the number 1? 1 is a rational number. What about the number 0? The number 0 is also a rational number. Let's look at this decimal here, 3.24159,876, and it goes on and on and on. This number here is irrational because the number is not a terminating decimal, nor does it repeat itself. If you have 5.321 repeating with a line over, that means you have 5.321321 repeating itself. Is this number rational or irrational? This number is irrational because you have a repeating decimal. All right, so that is all we have for today, guys, and I will see you all in the next video. Bye.